Hello, everyone. Good morning, good afternoon, wherever you are. We're glad you're here to join us for a webinar to learn more about fuel cells. If you're a commercial or industrial leader, you've come to the right place and can both get a sense of what fuel cells can do to help your business, but also pepper us with questions because we have ample time for that as well. My name is Katja Gagan and I run communications at Bloom Energy. And I'm joined today by Akhil Pateja, who is going to educate us on fuel cells in a way that's relevant for your business. And with that, I'm going to hand it over to you, Akhil.
Thanks, Katya. Hi, everyone. Nice to meet you. So my name is Akhil, and I'm the Director of Technology Strategy here at Bloom Energy. I've been at Bloom for about 9 years now, and I've worn a number of different hats across my career here, from helping us expand internationally to doing sales with the CNI space for a number of years. I spent some time in product management. I led our business development efforts for some of our hydrogen products, and now most recently, I'm part of the technology strategy team, helping understand our customer needs and mapping it against the future of our technology. Through my career, I've had the opportunity to meet with and work with a lot of leaders in the commercial industrial space. So I'm really excited to share some of those insights and what I hear from them as some of their challenges and the opportunities. So before we start, I just wanted to point out the picture I've used as a cover slide here. This is a roughly 30 megawatt installation that we have in Korea. And you can see the fuel cells here in their full deployment. And it really is a picturesque site, so I really love it. And it just shows the scalability of the technology. With that, let's jump in. So since this is a 101, I thought I'd start with some really fundamental basic facts about fuel cell technology. First and foremost, fuel cells are a form of on-site generation and they produce primary power. What does that mean? So on-site, pretty self-explanatory. We typically install these systems on the customer's premises, and they produce power for the customer to use and avail of. Primary power. So what I mean by that is not a backup solution. Our fuel cells are always producing power that is available to our customers. You often hear other types of fuel cells that are used more in the backup context, but that is not our technology. We are very much primary power. We produce power at a very high quality. It's uninterrupted. For those of you who are familiar with a device called a UPS, it's very similar to the output of a UPS, where it's a very clean, very suitable waveform for sensitive electronics and manufacturing, and it runs continuously. It's a very well designed system from the resiliency point of view, and we're going to see how customers capture some value from that later on in this. We also run on pipeline natural gas. So one thing I hear is, oh, isn't that the hydrogen thing? And yes, these fuel cells can absolutely run on hydrogen, but today a vast majority of our systems run on natural gas. They're incredibly fuel flexible, so they can not only take natural gas, hydrogen, but also forms of biogas, and they can run on blends thereof. But just from commercial availability point of view, natural gas is available today. So I touched upon the reliability, but we're often work with customers to hit certain levels of statistical dependence that they require, and we can go even beyond the five nines. And we can do this in a way that's more cost efficient and captures the most value for our customers compared to any other technology. We produce this power by converting the natural gas into electricity without combustion. So that means there's near zero NOx, SOx, and particulate matter. That near zero air pollution is another real value driver for our customers and a really important part of our offering. They're scalable. We can, if you look on the right, I've got this picture of like another site that I think is in the tens of megawatts, and you can see I often describe them as Lego blocks that you put on and you just copy paste over and over again to hit the scale that you want. So we've seen customers go in larger and larger numbers as the company has grown. Finally, and arguably most importantly, we're price competitive with other forms of energy generation technology, of power generation technology. This has not always been true in my time in Bloom. 15 years ago, 10 years ago, even 5 years ago, there was definitely a premium. But Bloom's been doing a lot of work on cost reduction, been really consistent about it. And today, we are at price parity or better than other forms of power generation. So I often hear a lot of myths, and I touched upon them. One that I always find fascinating is, aren't they batteries? So just to be very clear, batteries are a form of energy storage. You put in some electrical energy, and at a later point in time, you can pull that electrical energy out to use. We are not that. We are a form of power generation. We are constantly producing power for our customers to avail of. The other myth that I find very fascinating and often hear is, if they're so good, why aren't people using them? And to that, my response is they very much are. Bloom alone has over 1.5 gigawatts of fuel cell technology deployed across 1,200 locations all around the world. On the left, I'm just drawing attention to one of our recent announcements, maybe from like a few months ago, with American Electric Power. So AEP is the U.S.'s largest owner of transmission distribution assets. They're a pretty massive utility, and they're seeing a huge need of power from their customer base as data centers come online, manufacturing gets reshored. So they're recognizing the benefits of our technology and signed a deal with us that's up to a gigawatt of deployment. On the right, I've got just a spattering on some of our customer logos that have chosen to use us over the years. And as you can see, we touch a wide number of industries and solve a wide number of problems for our customers. Fundamentally, though, customers choose us for when it comes down to really four reasons. One, time to power. Very often, these customers are expanding their facilities. They're building new facilities, right? Their businesses are growing, and they need power to support that growth. They reach out to the utility, and the utility says, "Hey, we're happy to get you power, but it's going to take 2 to 3 years or 3 to 4 years," and those numbers are getting worse and longer. Businesses can't wait; they need power now. So we are able to deliver a power solution to customers in as short as 90 days, and that's incredibly valuable for a company that's trying to expand its business, realize some revenue, expand its manufacturing to take advantage of some demand. Second, resiliency. So we're going to talk a little bit about the technology, but our system design is highly reliable. It can operate at a very high availability and make sure that the power is always available to the customer. This is really important, right? You don't want to be in a hospital and lose power during a surgery. A data center company is spending unimaginable amounts of money is on NVIDIA chips and all this infrastructure, and they don't want to waste a second of not using it. So that resiliency really is something that customers value and work with us on to really come up with the best solution for their particular needs. Third is the cost competitiveness. Energy can often be a pretty significant part of OpEx for a lot of industries and a lot of companies, and we can come in and help reduce that burden. That's value that's created directly for the shareholder and for all the stakeholders involved with that company. Finally, and importantly, it's also sustainable, right? So we're very efficient technology. So the amount of natural gas we use to produce electricity is very low because we convert it at a very high efficiency. That means that we produce less CO2, significantly less than any other form of gas-based generation technology. Also, because in the non-combustion, there's near zero NOx, SOx, and particulate matter. These local air pollutants are often linked with cancers and other forms of health issues and can also provide challenges in permitting. Um, so it's really a combination of those four that we see these customers working with us and going with us for. So when I talk to customers in these spaces, I hear that they're facing some challenges. What am I hearing exactly? I'm hearing that the grid is having infrastructure problems. There's shortages. There's not more outages. Not only are there more outages, but they're also lasting longer, having a more tremendous impact on on operations. Furthermore, demand for electricity is increasing, whether it's industry reshoring, whether it's this AI data center boom, which is extremely power hungry and consuming every kilowatt available. There's an unprecedented demand for power in today's world, and it's just new generations not coming online enough, right? We're trying to build more plants. We're trying to build more gas plants, solar plants, battery plants, and all of the above. And interconnection queues for generation assets are getting longer and longer. I've seen some regions where they can be reaching 8, 9 years. As a result, what does this mean to the customer? It means that they're struggling with the reliability of their power, the affordability of power, and the availability of power. It's a business critical need, and they're starting to own their own destiny, and they're starting to take control of this problem by exploring on-site power. So on-site power is when they install some form of energy power generation asset within their campus. On the left, I've got some of the other options that they look at. There's gas engines, there's diesel backup, there's surplus storage, and these all do different things and solve different sort of problems, right? So natural gas engine takes in natural gas and produces electricity. It can run continuously. It can run as a backup, but it is a combustion-based technology. So it's really loud, it's noisy, it's tricky to permit, and it takes up a lot of space. The other option they often do, especially more for the reliability needs, is a diesel backup, where they say, hey, if the utility goes out, I will have this asset sitting on site that can step up when the utility's out. I always describe the diesel as an asset you spend a lot of money on and hope to never use, particularly because it too is extremely noisy. It's difficult to maintain. It has a lot of local air pollutants, and it too is getting very challenging to permit. On the bottom, we've got solar plus storage. This is something we're seeing more and more of, where companies install solar and they put some batteries on site, and it can help. However, its challenges it doesn't address all of the power of needs of a company, right? There's limitations on real estate, right? Specifically for the solar, you need a lot of land and space to generate an appropriate solar, especially if you're a power hungry user, like a manufacturing line, like a data center, like a hospital. Furthermore, the storage is great. It allows you to store it over what you produce in the day and use it at night. Kind of solves that temporal problem. But storage is expensive, and for a lot of the load curves that we see from customers, it's a lot of battery storage that they need to meet this need. On the right, we've got the fuel cell technology that from Blue Energy. As we dive in, let's talk a little bit more about fuel cells. So first, a little bit how it works. So I'm going to draw your attention to the top, where I've got a side-on view of the fuel cell itself. This is the fundamental building block of the technology. I'm going to age myself a little bit with this reference. When you look on it head on, it's roughly the size of a floppy disk. But from the side, how you're seeing it right here, it's extremely thin, roughly like 110 nanometers. So it takes in natural gas and takes in oxygen, and through a direct electrochemical process, it converts that to electricity. So what do I mean by that? What does direct mean? So if you think of like a natural gas engine that I had on the previous slide, or a turbine, or some other form of producing electric natural gas, you have to go through a number of steps. First, you have to convert it to thermal energy through a combustion process. Then you have to take that heat and move a turbine and convert it to mechanical energy. Then the mechanical energy is used to excite a conductor in some magnetic fields, and that's converts it to electrical energy. So there's like a three-step process there. Well, we have that one direct step. Second, this is a non-combustion, as I said before. So that means by there's no NOx, no SOx, no particulate matter. Third point that I really want to leave with you on this top part of the slide is that there's no moving parts in this fundamental, like in the fundamental part of our technology conversion process, right? That you can see here, it's a static cell, it's a solid state device with no moving parts. So on the bottom, I show how we take that technology and scale it to those hundreds of megawatt scale that we were talking about earlier, right? So we copy paste that fuel cell over and over again into a stack and put a number of stacks into a power module. Each power module is an independently operating power station. So we put 5 of them together in an energy server along with some fuel processing and some power electronics, and we call that an energy server. That energy server piece can be copy pasted over and over again. If a given power module goes down within an energy server, the rest continue to operate. So the customer is really never losing power and has that really high availability, right? Especially if you think about a site in like the scale of the hundreds of megawatts, 65 kilowatts is really a small fraction of it. Furthermore, you can they're intimately maintainable. So when it comes time to maintenance, you need to replace some filters or something like so there's a moving like a blower can need to be replaced, something like that. You can do repairs on each individual module and let the rest operate. This is a tremendous value driver for our customer. In fact, that resilience and reliability has been proven time and time again in the field, right? We've had typhoons that we've run through in Japan and Taiwan, earthquakes. I live in California. We just had an earthquake. Gosh, maybe it was early this week, and it's pretty severe. But technology just runs right through it. Utility outages. This is something I've often gotten feedback from customers on how valuable and how incredible it is. It's able to constantly to, to constantly run through despite the fact that the utility is down. Physical damage. This is one of my favorite stories here at Bloom. We have an installation here in the Bay Area that's by a hill. Somebody left a parking brake on what I guess is a forklift or some sort of truck on the hill. The forklift rolled down that hill and fell onto our systems. So the systems that were crushed under it, the safety sensors recognized something wrong immediately, shut down safely. But the rest of the systems continue to operate. And they had to call us to let us know what happened, and then we de-energize the system and help them come in and lift it up. Lastly, we've seen fire damage, right? Like we've had wildfires come up within inches of our system here in California. On the bottom, I've just got some statistics. Like that availability number of 99.8% on the fleet is something we're incredibly proud of and spend a lot of time making sure that we're able to maintain because we know it's really important to our customers. Um, and different customers take advantage of that in different ways, right? So data centers, we talked about how much they're spending, but they're also signing SLAs and like terms with their end users to make sure that they're guaranteeing a certain amount of uptime. The semiconductor space, right? They're spending millions and millions of dollars on ASML equipment and processing these wafers, and these are extremely sensitive, right? You cannot have them lose power. Excuse me. And be stuck somewhere halfway through an operating process. Hospitals, right? I mean, it goes without saying how mission critical that is. And retail stores, they often have refrigeration, they have food that they don't want to get spoiled, right? That those margins on those businesses are so incredibly thin. Any spoilage is a major problem. And that's why our customers are choosing us for reliability. They're trusting their core parts of their business with us. Some of the other parts of our value proposition is the time to power, right? So I talked about how we can be available in 90 days. Really, two things to think about there. One, on Bloom's side, we've invested a lot in our manufacturing supply chain. So we have a gigawatt scale factory that's 1 gigawatt per year of production in California today, and we've announced how we're doubling that over the next 12 months. We do final assembly in Delaware, and that factory is fully scaled, ready to go. Um, there's a supply chain that we've worked very hard on that's extremely robust with dual and triple source for all key components that sits behind that to empower that. Second, I mean, it's one thing to get the fuel cells on site, but to get them operating, you often have to work with permitting and other agencies. Permits are often the longest tent a pole in that tent. Um, because we're non-combustion and we have that low NOx, no SOx, no particulate matter, and that the near zero local air criteria pollutants, permitting agencies often look at us a little more favorably. In fact, here in California, which is some of the strictest regulation around air permitting in the world, there's a couple of jurisdictions where we're exempt from the air permitting process. And that's something we have a lot of experience with. And if you are interested, please reach out to our sales team with your particular site, and I'm sure they can help you think through what it means for your specific geography. We talked about cost, right? So we can be pretty aggressive and reduce 20 to 25% of total electricity spend. The cost of electricity varies dramatically depending on the scale, depending on the configuration, and a whole host of features. And somebody from our sales team would be happy to understand your specific site and needs a little better to come up with a quote if it's interesting. But I've put some general numbers out there. Some other levers of our value proposition, right? So we've got an extremely power dense solution. If you have lots of land and you want to lay it out flat, we can reach 30 megawatts an acre. But we can do clever things like stack them on top of each other. And 2 layers will get you 55, and 4 will get you 100 megawatts an acre. In some areas, this is incredibly important. We have a lot of installations in Korea, New York, the Bay Area, where land's at an absolute premium. So a lot of customers are taking advantage of these tower configurations such that they can use their real estate for their actual business and their core activities. On the pollution emission side, right? Because we're more efficient than some of those other technologies, we produce less CO2. We talked about the near zero NOx, SOx, and particulate matter because we're a non-combustion process. Water. Typically, power generation is an extremely thirsty endeavor. Our fuel cell consumes zero water during normal operations. So we consume a very tiny amount when we start up for the first time, but once we're up and running and operating, there's zero water that we consume. We often describe ourselves as water neutral. Finally, and most importantly, especially because we're on site, we're extremely quiet. The official statistic is 65 decibels at 10 feet. But the way I like to describe it is very often I host customers and show off the fuel cells that are powering our headquarter building. And when I'm talking to them right in front of that facility, we can have a normal conversation and you can barely hear the fuel cells. In fact, the freeway, that's about half to 3/4 of a mile away, is significantly louder. This is incredibly valuable for something that you're going to put on your site and really unique in the power generation space. Some of the other ways customers realize value is you can also take some of the waste heat from their exhaust and use it in a meaningful way, right? So, um, if we're just running electricity, our efficiency is 54%, right? So about 30 to 35% more efficient than some of those other gas-based technologies I showed earlier. That's pretty huge. But the question becomes that where's that 46% go? And a lot of that goes into heat. So we can capture that heat and take advantage of our exhaust, which is around 400 degrees Celsius, and do a number of things. I've seen customers heat up water that's used to heat up the district or provide heating to the building. Customers have used it to generate steam and use that for their industrial processes or chemical processes. Most interestingly, and my personal favorite, is to run it and produce cooling. So there's a device called an absorption chiller, which can take that waste heat and convert it into cooling. This is incredibly useful for a number of different facilities, whether it's manufacturing, data centers. In fact, our factory here in Fremont, California, uses this technology where we take the waste heat and run the air conditioning from the waste heat flower. This can take that efficiency combination all the way up to 90% and reduce carbon emissions significantly beyond. So, as a last thought, I just put together like a quick summary of the different levers of the value proposition. I think I've covered most of these. One is the load following, so that's becoming really important for the data center space. Because we're a direct energy conversion process, like I described earlier, we can respond to changes in customer needs about twice as fast as other technologies. And there's clever things we can do to even enhance that further to get like customers responding on like the millisecond scale. And it's extremely modular technology. The other part that worth mentioning is those ladder Lego block thing. So as you install it, as your facility grows, you can add more and more. With that, just one last plug. If this is interesting at all to you, on our website, we have a little value calculator that can work with you and help you quantify some of these different levers of the value proposition so that you can really understand exactly what the implications are for your site. Also on our site, you'd find ways to reach out to our sales team, and they'll be happy to connect with you.